This problem is a little bit different from the previous one because we're going to deal with sets instead of numbers, right? So suppose we have some set, right? And we take a subset, a fixed subset B of A, okay? Now we consider the set parts of A, which means all the subsets of A, in particular B, right? And within this set, we're going to define this relation. So X and Y are subsets of A, okay? And the X is related to Y if and only if the intersection with B is the same, okay? This is how we define this relation. We have to prove first that this is an equivalence relation, and second, we have to determine the quotient set of the parts of A with this relation, and finally find that there is a bijection between this set and the set parts of B. Okay, right. So let's begin with the first. But it's trivial that this relation is symmetric because, is reflexive because X intersection B is equal to X intersection B, obviously, right? This is a tautology. So it's reflexive. Then it's also trivial that it's symmetric because it's an equality, okay? And equalities are symmetric. So if this is equal to this is equal to this, which means that if X is related to Y, Y is related to X. So it's symmetric. And transitive is also trivial because if this is related to this, so X is related to Y, and Y is related to Z, okay? So you see, this set and this set are the same, so these sets have to be the same, so that means that X is related to Z, okay? So it's also transitive. Right, so it's an equivalence relation. Now let's go for the second part. The second part is more interesting. So we first need to determine what are the equivalence classes, okay, of part of this set with this relation. So in other words, what are the elements of the quotient set? So the equivalence classes are all the sets in parts of A, so all the subsets of A, with the property that the intersection with B is a given set C, right? So all the subsets X having the same intersection belong to the same class because they are all related to each other, okay? And if they have different intersection, they belong to different classes, obviously, because they are not related to each other. Okay, now notice that C, the intersection of X with B, C is a subset of B, okay? It's part of B, right? Because it's the intersection of B with something else, so it's a part of B. Not only that, the intersection of C with B, because C is a subset of B, is just C. So C is part of the class. So actually we can take C as the representative of the class, right? So for any C, which is a subset of B, we can define the class generated by C, and it's the class of all subsets of A, whose intersection with B is precisely this set C. All right. Okay, now let's establish a bijection between this set, so the set of class of this equivalence relation, right, with the set parts of B, so the subsets of B, so all the sets of this form, subsets of B, right? Okay, now if we take an element here, C, well, we pick the representative, which is a subset of B, and that is going to be the image, okay? Right. So this defines a mapping, and if we take different classes, so C is different from C prime, that means that C intersection with B, which is C, right, is different from C prime intersection B, because if they are the same, then these two classes will be the same, right? Since they are different, it means that the intersection, that the two elements are not related. So this is not equal to this. But this is C, as I said, and this is C prime, because they both are subsets of B. So what this means is that C and C prime have to be different. So if two different elements have different images, this is because this is injective, okay? And obviously there is an inverse relation, because if you pick any C here, it defines a class here. So the mapping can be reversible, so this is a bijection. The bijection between these two sets essentially means that they are isomorphic. So in other words, that there is a one-to-one association between the elements here and the elements here. The association is clear. If you pick a class here, what you have to pick is the representative in B of this class, and that is the image in this other set here, okay?